I'm Stephen Hevern, and I'm a Senior Technical Account Manager at AWS, and I'm based out of Philadelphia, Pennsylvania. Welcome to AWS Supports You, where AWS support experts provide tips to optimize performance in the cloud, lower costs, and provide you with best practices and design considerations. Joining me today are Kiran and Vivek from AWS Support. Can you give us a quick introduction?
Thank you, Stephen. Hello, everyone. This is Kiran. I'm a database specialist technical account manager based out of Dallas. I work with enterprise customers, review their instances, and provide the operational best practices. Thank you for joining today's session. Over to you,
Vivek?
Thank you. Hi, everyone. My name is Vivek Singh. I'm based out of Texas, Dallas, with AWS for last 7 years, and I also work with the enterprise support customers for optimizing and database overview for their databases, specifically RDS and Aurora PostgreSQL. Thank you.
Thanks for the introductions. Today, we'll be introducing you to Amazon Aurora, focusing on cost optimization with Amazon Aurora. Before we get into the details, a quick note to the attendees online. Use the chat window on the right-hand side of your screen to let us know where you're joining from us from today, and share your thoughts and questions throughout the episode. We look forward to hearing from you. We'll also provide a link to our survey, so if you'd like to let us know how we're doing, please click on the link and provide your feedback. Kiran, you want to start us off?
Yes, thank you. So, hello everyone again. Today, agenda is we will be touching on the various Aurora cost components, followed by the how can we monitor the Aurora cost, every component, and we will also look how can we track these each cost components, and then we will see how can we create the cost allocation tags, and what are the different various tools that are used in AWS to track the Aurora cost components. So without any delay, let's get started. So to just give a quick introduction about Amazon Aurora. Amazon Aurora is a database that we built ground up for the cloud. It offers simplicity and cost effectiveness of open source databases, fast and speed of the the commercial databases. Amazon Aurora is comes with drop-in compatibility with MySQL and Postgres. With these two engines, that means if your instances running on these two instances, you don't need to rewrite the code for these instances. You can simply bring in those instances up for the Amazon Aurora. And the last one is Amazon Aurora licensing cost. It does not have any licensing cost for Aurora. You can simply bring your instances as it offers a simply pay as you go model. So these are the Aurora cost dimensions that we are having. Every Aurora cluster comes with these three important dimensions. One is for the Aurora cluster, which comes as a compute, storage, and I/O cost. The other one is the DB cluster, which comes as a backup and data transfer cost. The other one is the features. So we will dip on all these three dimensions. We will go through each and every component in detail. We will see how how can we optimize each and every component based on the cost. So to just give an example, most of the time that we get the customer saying that the cost is more for the compute or the storage. How can we optimize them? So those are the things that we will focus on today's session. And coming to the backup and data transfer, it is based on your storage usage of your backups. So if you're having an instance, let's say for example 1000 GB of storage, then you will be charged only if you are exceeding the limit of the Aurora storage. That means until the 1000 GB of backups will not get charged. Likewise, the same with the data transfer as well. You will not get charged if you are doing within the region AZ. If it is going outside the different AZ, then the charge will be based upon your usage. And coming with the innovative features of Aurora, that is we have many more innovative features that are coming, like a global database, snapshots, export, and the fast cloning, and Aurora backup, backtrack, parallel query. All these are the innovative features that has been introduced by the Aurora. You do not need to pay much for this one, as you when you enable these features, you will be only charged based upon the consumption of the IO and the storage. Based upon the storage, like data transfer and how much the data is replicated from one region to the other, that is where the cost will incur. So that's where the Aurora charges you on based upon the features usage. So without any delay, let us understand each and every component in detail. So first we will discuss on the Aurora cost compute. So cost compute comes as I mentioned, 30% of the customers come to us like asking for various understanding, like where the cost is coming up from. Like for the instances, if you are over provisioned the instances, that is where the cost you can significantly reduce the cost. For example, if your instances is overly provisioned, right, and you are seeing that the instances are running on on a less CPU, or there are certain KPIs that we call it as CPU utilization, memory, query responsive time. All these will have to be taken into the consideration while making a decision by the database specialist to understand if this instance cost is correct or not. So there are ways that we can monitor this instance cost, keeping a track of these instances cost, creating a baseline for this cost. Like for example, if your instances are running and you have created the CloudWatch alarm, it will trigger an alarm saying that for this specific instance you are seeing the cost of this much, right? Like for example, like $1,000. So you wanted to trying to decrease the store instance cost. Then how can we do that? Using different tools like trusted advisor or cost utilization usage report, that we can track of these reports, and this will basically provide you an estimate of these charges. So trusted advisor is something like it is a cool tool that you can use of, it not only provides you the optimization of the cost, it also provides it fills the gaps of the security performance, or it will basically detects any instances having any underutilized instances, and it will provide cost optimization techniques that you can use to save the cost. And the next one is it provides you a comprehensive report where you can use the S3 bucket. You can have your own S3 bucket and send these reports to the S3 bucket, and you can retrieve that based upon your usage. If you wanted to retrieve the information for every hour or every day, you can get those information based upon creating the tags. You can also integrate the CUR report with Athena, where you can get more detailed enhanced report of this cost analysis. And right sizing of your instances is basically dependent of various factors. Like you have to understand how your instances are running during the peak period, right? You have to also understand when it is low period, like how the instances are costing, and based upon that you can get a proper estimation, right? Like if you are expecting any load in future, let's say if it is going to go on any website, if it is going on a live next week, you're expecting more customers or something like that. That is where you can just increase the instance classes, and then you can come back if once the workload goes down. So there are certain ways that you can see, as I mentioned, you can create an alarm, right? You can see the utilization of the instances. Based upon your utilization, you can tweak these instance classes. So what are the ways that we can optimize the instance cost, compute cost? So if you are using the default on-demand instance classes, which offers it provides a significant if you are moving to from on-demand instance classes to the reserved instances, that can provide you a significant cost savings, because for reserved instances, the moment when you enroll to a particular instance class, you are signing up for this particular instance class for the next 1 year or 2 years on a lease, then there will be a significant amount of reduction of the cost by 42%. That's how, if you're having a steady, and if your workload is more indexed and you wanted to see your instances all the time up and running, that's where the reserved instance class will come into the picture. You can take an advantage of the reserved instance class. Scaling up and down based upon your usage, as I mentioned, based upon your CPU, memory, and network throughput. Based upon these things, if your test environments which are running on the low environment, and you wanted to save some cost, you can always tweak that value to the lower instance class, which are not being utilized, because most of the time, periodically they do not look at for the utilization, right? So the best way to optimize the cost is to always keep an eye on these resources utilization. That way, by keeping these instances wherever there is a chance to uh, reduce the instance classes, that's where you can use these tools and take an appropriate call for that. And coming to the other one is like start and stopping the instances. I've seen multiple customers who has an intermittent load where their instances wanted to run on particular time only, and do remaining the period, they can stop. So you can always stop and start the Aurora cluster based upon your load. And coming to the read replica, if you not utilizing the read replicas, and if it is underutilized, that is where the Aurora read replica come into the picture. Like if there is any unpredictable pattern of the workload, like read queries are coming up, that's where you can spin up an Aurora auto scaling feature that can basically do the scale up and down horizontally based upon your usage. And now coming to the smaller instances, if you're having the test instances, you can always tweak them to the lower environment. You can try with the T instance classes instead of going for the R or M5 or something like that. So database consolidation is another way that you can see. Let's say you have in a small databases that you wanted to see a better improvement, right? You can also consolidate all your smaller database into one Aurora instance. That way you can have less usage of the instances instead of spinning up multiple instances. That's why you can save a lot of cost in that. And Aurora serverless is something that you can also always consider about it. But if you are having any unpredictable pattern, or if you are having an intermittent load, that is where the Aurora serverless comes into the picture. If your workload is steady, and if it always needs to be indexed, this always needs to be run up and running, that is where you can always switch to the provisioned instance instead of going with the Aurora serverless. So provision instances, again, you can choose the reserved instances. That is where you can save a lot of significant cost saving. And tuning the workload can also help to reduce the usage of the instance classes, because sometimes if the instances are not properly, workload is not being properly tuned, then there will be a cost incurred for each IOPS and as well as the instance of the memory. So always pay attention on this one and see if you have any way that you can choose to take an appropriate call to make the cost reduction. Then obviously these are the techniques that we can use. Now let us understand what are the various ways that we can monitor and track based upon the storage. For the storage, it is always important to notify that storage is billed as per the GB on per the month. If it is always charged as a prorated rate. For example, if you can see here, uh, you are coming up with 1,000 GB of database, right? And you are expecting everyday growth of 20%, right? That is where 20 GB increment, right? So in the next day it will be calculated as a prorated. For 30 days it will be charged for 1,000 GB, and for 29 days the 20 GB will be charged, and for the rest 28 days additional 20 GB will be charged. That's how this Aurora cost, storage cost, is prorated way that it will charge. And how can you monitor this one? It is used based on the volume bytes used. You can have this watch metric that you can always create an alarm that it can provide you the information, like how if the storage is going up and down, based upon that usage. And coming to the optimizing, how can I optimize the storage cost? This is also one of the most important recurring question that we often get from the customers. Partitioning the large tables, partitioning the tables does not only help to reduce the storage cost, but also improve the significant amount of it can help significant amount of the performance, right? So if you're splitting the database into the smaller sections, that way the less number of IOPS will be incurred and the storage will be less. That's how you can see the performance will get improved by doing less scans, table scans, right? So that's where, like, you can always see if there is any chance that you can partition the large tables. And always, if there is any older partitions which are not being required or unused tables, you try to drop them off, because with the automatic resizing of Aurora, that if you drop or delete any tables, it is going to retain the storage back to the normal. Because let's say, like, if you have a storage table of 100 GB, and if you have deleted, and you will can reclaim those 100 storage. Prior to this one, like, it was not that case, like, it was not used to reclaim the space. But with Aurora automatic resizing, you can now resize, like, by dropping or deleting some of the tables can always reclaim the space. And you always need to understand what is the purpose of me storing this database, like, on if the data is not being utilized for longer time, like that's where the data archiving can come into the picture, right? Archiving is nothing but you are just purging, or you are just archiving your data to the S3. There are various ways that you can use of, like, you can archive it to the S3, or you can archive it to the longer duration. Like, you can save so much of cost, right? Based upon your application needs, you can always take this option as well. And purging and unused data indexes are also one of the important thing that can help you with optimizing the cost. And the other one is the data type consideration. That data type consideration is also an important way that gives you a significant amount of storage cost saving. Because, like, let's say, like, being myself and a DBA, like, we usually create an data type by based upon the usage of the data, right? Like, we aggressively look at that one. We think that the upcoming load is going to come. Let us basically provide the bigger data type instead of doing the smaller one. But that's not how it works. Like, if you always, you can tweak that value, the data type changing, you can always change that based upon your usage. Let's say, for example, you have a like, you have a customer ID, right? Like, where you are expecting customers of 15,000 customers, right? That's where you can go with the small int. Later on, like, if you see the customers increasing from 15,000 to somewhere around 30 or 40 or anywhere, you can change the data type to middle int, right? So based upon the data type, like, integer, or better to choose the appropriate value. That can also save up a lot of cost with the storage. With that said, like, I'll take a pause here to understand if there is any questions.
Thanks, Karen. We do have one question from the chat from JibJab06. They would like to know how they would start and stop an RDS MySQL database on a daily basis.
So here we can do create and automate this one, like, by using the Lambda. There is a blog that we can use where you can automate the script by using the Lambda. Like, you can just simply run it on that, or you can have the shell script that is running on the EC2. You can just try to automate this process, like start and stopping that one.
Cool. And I think we can share that out with in the chat.
Sure. Yep.
Great. I actually have a question, if you don't mind.
No
when you're talking about being able to stop and start the cluster as part of the cost optimization when you're not using it, are you able to stop a single instance in the cluster to save some cost?
So the single instance, yes, like, as the cluster, it comes as an writer instance and the reader instance. So you cannot stop the particular instance. It is basically, when you stop the instance, it is entire Aurora cluster will stop. There is no way that you can stop the particular instance.
Cool. Thanks. There aren't any other questions, so I believe we're turning it over to Vivek.
Sure.
Thank you very much. So thank you, Stephen. Thank you, Karan. So in this section, we are going to learn about what are the best practices to optimize Aurora IO cost. And Aurora IO cost is one of the topmost question asked to me, that how we can save Aurora IO cost on PostgreSQL and MySQL engines. So let's go ahead on this one. So there are two kind of the Aurora IO cost on the Aurora instances clusters. One is the read IO cost, and the other one is the write IO cost. So how do we define read IO cost? So whenever your read workload reads or scans one data page on your cluster, that is defined as one read IO. So like for example, on the MySQL engine, the page size is 16 KB, and on the PostgreSQL Aurora, it's 8 KB. So it does not matter. It is going to scan one tuple or one row from each page. It depends on the number of the pages scanned for the read workload, and that defines your read IOs. And how to monitor the cost for the read IOs? We have a CloudWatch metrics called build volume read IOs that tells you that how many read IOs has done on that particular cluster, as well as instance levels too. Going to the next page. Here we are going to learn that how to optimize IO cost for the reads on Aurora. Number one thing is that optimize your SQL query to read the data from memory. The data read from memory are not counted towards the read IOs. So we want to make sure that we have enough memory or shared buffers in PostgreSQL, for an example, to contain the workload, to contain the data pages for the read workloads. There is one of the quite popular CloudWatch metrics called buffer cache hit ratio that straightforward tells you that how much data is being read from buffer, and it should be around 90 to 95%. That is the nice value. Lower the value, that means some or most of the data are coming from your storage. That would be counted against read IOs. So make sure that you tune your database parameters to have the higher buffer cache hit ratio. Higher the buffer cache hit ratio, that means most of the data are coming from memory, and that's how you will optimize your read IOs. Next one is that optimize the right sizing of your databases instance. For an example, higher the database instance, higher would be the total RAM, and that's how higher would be the buffer cache. For an example, in PostgreSQL, Aurora assigns around 70 to 75% of total RAM towards shared buffers. So higher the total memory, higher the buffer cache, and that would be useful for your read workload. It's very important that you keep your eyes on the large tables. If you have some large tables, say like 1 terabyte, couple of terabyte, and if somehow the workload is doing full table scans, that will generate a lot of read IOs. So make sure to do the partitions on the large tables so that the scanning is happening locally on the partitioning, and that's how you can parse the old data easily. And the last point is that avoid doing logical backups. For an example, in PostgreSQL, we have pgdump. In MySQL, we have MySQL dump tools. What it does that it will scan all of the pages one by one in order to take the logical backup, and that will be counted towards your read IOs. The workaround is that you can use Aurora snapshots. That might be easier way compared to logical backups, unless it is needed. There are some cases like pgdump or MySQL dump can be used if you want to back up some of a particular object, but Aurora cluster level backup would back up everything. Moving forward to the next slide, here I'm going to discuss that how we can use Aurora PI performance insight in order to find the top SQL queries consuming high read IOs. So there are some of the counter metrics in the top, such as block hits, block read, that is defined as BL case underscore hit, BL case underscore read, and tuple phased and tuple return. So block hit tells you that how much data is being captured from memory for your read workload, and block read tells you that how much data is coming from storage. So we need to have the higher block hit percentage in order to make sure that most of the data are coming from memory. And in the bottom, you can find out that what SQL queries are assigned with those spikes. So once you get those SQL query, you need to run the explain plan and go through one by one and find it out that is there a quite a major difference in the tuple fetched versus tuple return. You might need to use the PostgreSQL extension. In the case of Aurora Postgres, it's called PG underscore buffer cache. That tells you that what are the content in your buffer cache at that moment. You can also use PG pre-warm if you want to manually warm your data in the cache. So there are some certain ways. There are some blocks also already posted by AWS data blocks that tells you that how to optimize your SQL queries in order to save read IOs on Aurora. Next one, it comes Aurora write IO cost. So let me tell you that how do we define one write IO. So Aurora will group the write activity and the unit of 4 KB unit that is defined as one write IO. So this particular matrix you may see different on the instance level, but you when sum up it could be reduced, and it is defined by build volume write IOs. Write IOs are billed as per 1 million requests. Different regions might have different write IO billing rates, and I want to make sure that when Aurora in Aurora, what it does that it copies the data at the 6 places. So all those copying data are not part of the bill. It's the part of the managed services. So next one is that how we can make sure that we are optimizing our write IO. So make sure that you have consistent writing so that Aurora can group by the write activity in the shape of 4 KB. Remove any unused and duplicate indexes. There are some impact by these ones. Whenever you update or modify a particular column in a table which has assigned indexes, those indexes pages are also modified, and those also will cause write IOs. So make sure that you are keeping your eyes on the unused and duplicate indexes, and make sure to drop those ones if you are not going to use that. Next one is that limit to working data set. That means that try to achieve lean data set. If you don't want that data for the read or write activities, it's better to save somewhere else, maybe S3. I have seen many customers, they save application logs in Aurora Postgres or MySQL, and they don't use for any read or write workload. So any kind of writing that will cause your write IOs. So make sure that you are writing the data which is useful for your OLTP or OLAP workload. Otherwise, you can use something else like S3 or Redshift in order to save those data set. Logical replication, when you set up, that will generate the database log files such as vol files or bin log files in the case of PostgreSQL or MySQL. So make sure to use logical replication whenever it is needed only, because when you enable logical replication, it will generate the write IOs, because it will start writing those database vol logs and bin log files. Next topic is Aurora data transfer and backup cost. In this section, we will learn that how Aurora is built for the data transfer and how does the backup cost work with Aurora. So whenever your data crosses the region and that goes to different region, that would be the part of the data transfer. Any data transfer among the AGs, which is the part of database replication, Aurora's managed replication, this is not charged. It is a part of the Aurora overall billing. And any data transfer caused by Amazon EC2 instances across the availability zone, that would be the part of the billing. We have a couple of the cost monitoring matrices, which is network in bytes and network out. You can keep your eyes on these metrics and make sure that you are controlling the data transfer cost. some of the cost optimizations that use VPC endpoint whenever it is possible. So next one is the Aurora backup cost. You can take the snapshot manually, or you can work on the retention period of automated snapshot. There is a CloudWatch matrix called backup storage per GB, and then we have some other CloudWatch matrices for Aurora snapshot, which is total backup storage used, snapshot storage used, and backup retention period storage used. We want to make sure that there is no backup storage for up to total 100% of your Aurora database storage. For an example, if your database size is 200 gig, there would be no additional snapshot cost up to 200 gig size of snapshot. Manual snapshots within the retention period will not be counted for your backup storage, and the storage amount billed in a month is based on your average usage. So we want to make sure that we follow the cost optimization techniques for reducing the snapshot cost. One of these is that review and configure your backup retention. I have seen in many cases, some of the customers, they have set up higher retention period of the backup in the test environment or non-prod environment. If you don't need to use those old backups, better to reduce the retention so that you can reduce the snapshot cost. Other option is that try to avoid manual snapshots if it is not needed, because Aurora already takes automated backup, and that might be enough for your business use case. With that, I will take a break and let me know if you have any questions.
Hey, Vivek. Yeah.
Sure.
So we have another question from JibJab06. They have a question about Trusted Advisor. If we can run that, if they can run regularly scheduled automated reports to show that I'm always right-sizing my database.
So Trusted Advisor basically gives the information about all the unused, underutilized instances. So it's basically provides you the cost optimization techniques. Let's say if you have any instances that are underutilized, right? Let's say for this particular account and this particular region, it aggregates all that instances across all the regions and across all the accounts, and it will provide a detailed analysis and provide if you can, stop this particular instance, or if you can reduce the instance class, you can get benefit of the cost. Like that, it provides an extended comprehensive information for the report.
Cool, thanks. And Vivek, I have a question.
Sure.
So getting into kind of the details of some of this, is there a way to help identify or help customers be able to identify duplicate or unused instances?
Sure.
Indexes, not instances.
Yeah, sure.
Indexes.
So I have built an Aurora advanced monitoring tool. You can share that link, GitHub link, and under that GitHub repository, there is a set of SQLs used for that tool, and there I have mentioned duplicate and unused indexes.
Cool. Thank you. I think that's all the questions at the moment. So back over to you.
Cool.
All right. So let us understand about the Aurora features and the cost. As I mentioned, Aurora comes with more enhanced, innovative features that Aurora offers, like a global database. A global database is nothing but the main cost component is replicated when the write IOs on the demand compute cost on the reader instance node is the main cost is mainly occurs when you have the inter-region data transfer, right? So for the writer to the read-only mode, customer use this feature typically to get the global disaster recovery architecture, but where the cost is the concern, the best way to contain the cost, or size your reader node appropriately and balance your business, understand your business RTO and RPO. Based upon that, you can always see if the reader node can be sized smaller than the writer, such things that you can always do that, right? And the other way that you can use is the most important thing is like the headless cluster. It's a new way that you can always use to save some cost. So the next one is the cloning. That cloning is mainly used to create the logical cluster, right? It starts with generating the storage and IO cost. When charges if you see to if you start to see if you are not getting down on the clone due to the copy and write protocol, compute cost will be accrued on the when you spin up a clone instances. The best practice here is to simple create a db clone as needed on the basis only, and terminate if you do not no longer is using the clone feature. That's the way that I always suggest my customers. So another way is exporting the db snapshot. When you export the snapshot, Aurora basically extracts all the data from the snapshot and it stores in the S3 bucket, right? You can export either the automated or the manual snapshots. By default, all the data will be exported, but however, if you wanted to choose a particular specific set of the database, if you wanted to send only particular schemas or the tables, then you can send them as well using the select into file with Aurora. So all the data which is stored in the S3 are Apache format, Parquet format, and if you wanted to use that one, usually the size would be the 20 GB in size of the Parquet format. And the way that we can control here cost for this feature is try to avoid re-exporting the same snapshot. Instead, try to reuse the same generated Parquet file in one way. The other way, you can consider exporting them to the S3 and archiving it to the Glacier, right? So if there is a long-term retention, then I would say keeping them into the Glacier and then retain the snapshots for the long term. That's how you can save a lot of cost for the snapshot export. Now let us understand what are the cost allocation tags. So there are ways that we can create the tags as well as to view the report. So one is the way that you can view is the cost explorer, right? So the cost explorer basically provides you the comprehensive information, as you can see, if I'm say, for the total Aurora cost report, it basically generates the Aurora accounts and as well as the cost of the particular RDS instances or Aurora instances, right? So if you wanted to see how my RDS instances are running on this one, you can create a tag and you can see that report on the cost explorer. It's basically provide you the more comprehensive way that you can take a decision based upon the utilization of these instances. So when we are creating the cost allocation tags, you can always create by using the name. Let's say if your instances are smaller, right? And if you are a predictable pattern of the usage, and if you are not, then it is very easy to understand where the cost is incurred. But let's say if there is a large databases or dynamic application, where the data is unmanageably growing, and you wanted to see where the cost is going on, or if you are having a project that is coming up, right? You wanted to understand how much this particular project is incurred the cost, or if there is any test or dev environment that you wanted to keep a track of those, or if there is any production instances, right? For that matter, you wanted to understand how much is the cost for these particular EC2 instances or Aurora instances or S3, any of the RDS AWS services. It basically you can go ahead and create a cost allocation tags where you can give the name for it particularly and you can tag them. For example, here I have created the test, I have given that one and given the tag key as the DB environment. This is basically to get identified, to understand each and individual cost. So after doing that, you can just go into the billing, and then if you can see the cost allocation tags, if you on the left panel, if you click that one and if you click the activate, it takes at least for 24 hours to get this activated, and then you can see start looking at these tags based upon the Aurora usage. You wanted to track the usage of the Aurora storage. volume IOPS, or you wanted to track the usage of the IOPS, right? So if the IOPS is growing up and up, and the instance cost is just going unimaginably, like, expensive, then that's where, like, you can create the cost to understand where the cost is actually incurred. Let's say if it is going to the IOPS, then it is the time, like, you have to look that instance class is not properly configured, or, like, the query needs to be get tuned because it is not setting in the memory, right? So that's how you can better analyze by using these reports. Uh, you can always send these reports to Athena as well. Like, you can create an reports, and you can automate them and send it to the Athena. Like, you can use the cost in utilization report, as I mentioned, cur reports. You can also send them to the Athena. That way you can actually keep a track of this one. With that said, let us understand what are the other cost estimation tools that we offer from the AWS. Over to you, Vivek.
Stephen, do you have any questions so far?
I have a question that I'd like to ask in going
Sure.
through some of this. First, I'd like to say I'm a big fan of cost allocation tags. So if you're not tagging your resources in AWS, please do so. It makes things so much easier, not just from a cost perspective, but from a systems perspective. Sorry, I'll take my TAM hat off for that. So you mentioned Aurora fast clones. Well, how fast is fast? Or is there what's the use case around this kind of on an as needed basis?
Can I answer this question maybe?
Sure.
Sure. So it takes around 5 minutes. It could be plus minus few seconds. And some of the use cases that assume if you are using your on-premises database and you want to take the backup every night and you want to send for the BI purposes or testing purposes, the way which I was used to do when I was PostgreSQL before AWS, I would take a backup, maybe PG dump or MySQL dump, and restore on different instances, and that would be ready for the testing environment. In Aurora Fast Clone, it's straightforward. You cut the clone, and that clone can be used for the read or write activities. Make sure that if you write that data, that would be built. Otherwise, that is a separate cluster. You can create clone every day, and you can drop those ones. That is the use case. And one example is that if you want to upgrade your database, you can cut a clone, upgrade that one, and test your applications, making sure that it is working well. And we have a blog on blue-green deployment that also uses clone in order to save downtime during upgrade.
Cool. Thanks. No other questions at this time. So Vivek, over to you.
Awesome. Thank you. So many times customers ask me that, okay, we are good to move from Oracle to Aurora Postgres. Looks like cool database, but how want to make sure that how much it will cost to me? Would it be a lot cost or less cost, or am I going to save money or not? So let's learn about cost optimization tools supported by AWS. And number one comes here is AWS Price Calculator. If you plan to move to Aurora or any other database or any other AWS services, you can use this web-based planning tool where you can input some of your plans, like how large database instance do you want. Depending on CPU memory, you can choose the instance class and size and all. And then you can model the solution for the business need, what you are going to serve using Aurora or by RDS. And based on that, you can estimate that how much it will cost to you. You can review the calculation. You can change your solution. For an example, you can reduce the number of the readers, or you can scale down the instance class. And that's how you can plan your cost before moving to Amazon Aurora. And that's how you can plan your spend and find that what is the most cost saving opportunities for you. So this was the AWS price calculator, which generally is being used before moving to Aurora. And what happens if you are already using Aurora, then how you can keep eyes on the current usage. And also, we already discussed briefly about Aurora cost and usage report. This is awesome report. If you don't use, I would suggest to look at this report. This tells you the comprehensive data set and the cost and usage of the data. And the nice thing is that it also tells you the estimated cost. You can publish your AWS billing reports to Amazon S3 bucket, where you can query these data by using Amazon Athena also. You can break down the cost by hour, by day, or month, and then that's how you can, or even on the product resource and by the tax we just learned about, and that's how we can keep our eyes that which particular cluster or which particular environment is costing me more. You can pick that one. You can run the cost optimization particularly on that cluster or that environment. That's how you can reduce your overall Aurora cost. And yeah, like I said, that you can use Amazon Athena to query or to analyze the cost and usage report in S3 buckets. We are going to end of this session. So the last one is summary. What did we learn in this session? We learned about the Aurora cost components. The key components are instance class, storage, IO cost, and we also learned about that how to monitor. We learned about the CloudWatch matrices. You can also set up CloudWatch alarms based on those matrices, and that's how you will get notified when some of the matrix values are going above the particular value. And then you can measure the baseline cost of the application usage. You can use the AWS cost estimation tools and make sure that you are within your budget for Aurora. And we learned about Aurora tagging. By tagging, you can know that which environment is most expensive for you. You can control your budgets or spendings on that environment using cost and usage report. So these are some of the resources which include some of the tools and AWS data blog lists, which will help you to learn deeply that how Aurora cost optimization is done, what are the key factors for saving IO cost, and what are the tools for what we have for Aurora cost optimization. Yeah, so over to Stefan, if we have any question.
Thanks, Vivek. Actually, yeah, we had a question come in from JibJab06, and they wanted to know, can I program automatic shutdown actions on my accounts if cost level exceeded, or just an alarm and any shutdowns that would have to be manual? So I can actually answer this one unless you want to take it. So it wasn't talked about on the show today, but and I'll pop a link into it. But with AWS budgets, you can set budgets and thresholds, and you can do simple things like simply make notifications that somebody's getting close to or over a threshold in your budget. But more importantly, you can also take actions. So if you exceeded a budget, or a team looking at a set of tagged resources exceeds their budget, you can set some actions to then shut those resources down in order to manage your costs especially in non-production environments. So I'll pop a link out before we close out here for AWS budgets. But that's what you want to look for. I don't know if either of you have anything to add to that.
That's good. Otherwise, the basic way which I know that you can use AWS CLI, you can run cron job or Lambda, but looks like AWS budget is the better tool where you can automate in a better way.
Right, and you can hook into those actions as well.
Exactly.
So
exactly.
Okay. So no other questions at this time for you. Thank you very much for presenting. Do you have any last comments you want to get in before we close out the show?
I just want to say that if you have any questions about Aurora cost optimization, feel free to reach out to your technical account manager. And one of us or from our team would like to touch base with you and want to deep dive and look at all these options what we just discussed during this session.
And as I say that, we are getting a couple questions in.
Sure.
So Sarav Kumar 329, do we have an option to check the average query time in the database or tables consuming the most time and cost? And I think one of your tools might help with that.
Yeah, Performance Insight is the one, or else I have written the Aurora Advanced Monitoring tool. You can use that one also. That's a good point. And in PostgreSQL, I know that there are some database specific parameters. One is log statements, some parameter which will tell you which will let you log long running SQLs in the same way we have in the MySQL tool. log statement query, something like that. Let me find it out. Yeah.
Cool. And we had one other question from Kevin Tran's Aurora service recommendation on IoT use cases.
IoT,
So,
I have no idea. Yeah, go ahead, Kiran, if you have something.
yeah, Aurora serverless is more useful for the IoT. Yes, like if you have any variable workloads, right? Like if you have a multi-tenant applications, that's where the Aurora serverless come into the picture. And like if you wanted to use the mixed configuration, like with Aurora serverless, and if you are not sure, like if it is proper fit for your application, like you can always use the mixed configuration. You can spin up an instance with Aurora provisioned and also well use of the serverless, and you can always test your instances if you are mainly the Aurora serverless is designed for the IoT purposes, right? So you can use that one, and you can test always and see if that is an appropriate for your use case, and then you can always migrate it to the serverless instead of going with the provision.
Okay, cool. Anything else from either of you?
So in Postgres, there is a parameter called log minimum duration statement. Being DB, I would set it around like 5 minutes value. That will log all of my SQL queries running for more than 5 minutes, and I would run the extent on those ones. In the same way, I think in MySQL, we have something called slow query log file.
Correct.
And that's how you can log those SQL queries.
Cool. Awesome. So with that, so thanks again to both of you. Today we took a deep dive into Aurora cost optimization. If there's any questions that were not answered today, or if you have questions after the show, please head over to repost.aws. Post your question where one of our experts can provide you with an answer, and your question could become a topic in one of our future shows. If you have feedback for us, please check the chat box on the right for a link to our survey, or you can email us at awssupportsyou@amazon.com. We want to hear from you. Tell us what you would like to see in the show. Please join us next Monday, January 30th, 11 a.m. Pacific time, 2 p.m. Eastern time, when we'll be walking through the Dr. Pet program. Thanks again for joining us at AWS Supports You, and happy cloud computing.